The overall goal of this procedure is to measure total retinal blood flow using Doppler Optical Coherence Tomography, or OCT, and a semi-automated grading software. This is accomplished by first scanning the patient with Doppler OCT according to a dual-angle protocol. The second step is to automatically evaluate the quality of OCT images and detect blood vessels in the images. Next, the graders judge and revise the vessel location, diameter, and type according to OCT images and a color photograph of the optic disc. The final step is to calculate the Doppler signal and Doppler angle of the detected retinal veins and estimate the blood flow and velocity in each vein. Ultimately, total retinal blood flow is obtained by summing the blood flow in all veins around the optic disc.
The main advantage of this technique over existing methods such as laser Doppler techniques and ultrasound color Doppler imaging is that it provides total retinal blood flow measurements using scans taken in just 2 seconds.
Video demonstration of this method is critical as the steps are difficult to learn, and because the accuracy of result depends on the image quality and the subjective grading of vessel position.
Demonstrating the scanning procedure will be ophthalmic technician Janice Van Norman.
For this protocol, patients should be scanned using an RT-View Fourier domain optical